And for the past 5 years, I'm just like, I became professor in due course of time and everything. That's all done about my life. Of course, I'm in touch with our proud alumnus from NIT and very like senior to me, Mr. Gupta, since he was the director of technical education and made like a lot of changes in the state of Haryana technical education during his tenure as director. So I happened to see him during that time also, and like I was professionally connected, but of course the major connect came between us when like we organized one get together of his batch, and he was astonished the kind of the development NIT Kurukshetra Alumni Association has made and what are the activities we are undertaking. So this is all being done with the help of, with the support of, with the blessings of our alumni across the globe. Once again, thank you very much to this TERii family. I must congratulate on the concept this TERii family has introduced, probably the brainchild of the advisor, sir. It's a wonderful concept. Probably you come across with a lot of technical or other miscellaneous talks, and out of this talk, if few of you are benefited, even then 10 or 15 are you benefited, and you grasp any one good thing out of this 45-minute talk, probably his duty and the towards the society is done. So this is very important, very good initiative. I really appreciate. I never knew that this such kind of arrangement has been made, very elaborate, and such an ecosystem has been created over here. So I was told that you have to create, he was very humble in telling you, just invite, I invite you for a talk. But I never knew this is a series of talks and everything, and I'm going to be a part of this. Thank you very much, sir. Basically, I never wanted to be a teacher, but I've been a teacher for 20-25 years now. So, बोलना हमारी जिंदगी हो जाती है. So मेरे को आप पूरा time दीजिए. I will bifurcate my whole time with you in two parts. I'll make a small presentation of 30 minutes, right, so that you don't get bored. After that, we can interact. Whatever I've learned in 25 years, maybe the bit difference between you and me is only I was born 25 years ago. That's all. I was in those years 25-30 years ago. So probably you are in the learning phase. Whatever experience I've got in my life, I would like to share with you. And if some of you are being benefited, I'll be blessed. Let's start with the technical presentation. CA presentation, yes. Yes. I don't know what about the audience and all, I think, but this topic is relevant to kind of all major disciplines of engineering. Probably it relates to the product development, and you know that product development refers to even of course it's originated from mechanical engineering, but product development is common to all. Even you talk of the electronics engineering or maybe the CSIT or the mechanical engineering. I'll try to find interest in this talk for all of you. I mean all people from all disciplines. So the title is Computer Aided Engineering. Most of you have heard this, the engineering is being aided by the computers nowadays, and the computer aided engineering has become essence of our intelligent future or engineering innovations. Everybody is looking for innovations. I think innovations can be described in a very easy manner. Once you are modifying the attributes or functionality of any of the product, it becomes innovation. So nobody is reinventing the wheel nowadays. Everybody is modifying, and you people and we people are looking for new products every day or every week or every month, and things are happening by the industry or happened by the industry also. I have made this slide what the kind of industrial world we are living in, right? Thing is, there are these 3-4 guidelines where we can define the industrial world. One thing is the competitive pressures. Of course, there is numerous competitive pressures happening in industry, which are forcing companies to closely examine in which they develop the product, right? This is the major guide force when the people or the companies are developing the product. The competitive pressures become one of the major factors. Secondly, launching a new product. Whenever launching a product it has to be a habit by the company. You cannot go for go for a mobile and no new mobile comes up in the next 2 or 3 months by a company, it gets abolished, or because the product life cycle has changed now or shortened now. And consistently successful product launches have become necessity for the industry in this competitive world. Next is the survival of an industry means constant evaluation in order to retain the relevance and competitiveness. And we need to shift, the paradigm need to be shifted, paradigm and practices must be perpetually reviewed at every level of the company, reduce time to market, improve product quality and reduce cost are the most common requirement nowadays. We are stressing hard to reduce the market, or maybe, of course, the quality has become internationally accepted thing, and quality, we have to bring the quality, otherwise we will be no more in the market. So because of this customer competitive pressures and such kind of requirements, we need to develop the product on a very regular basis, and that should be it has to be very successfully done by the company. This slide belongs to how the things have changed from in the last 2, 3 or 4 decades. You must be remembering once you talk your fathers, or there was only one bread coming up, and the call is a Britannia bread. We never knew what is the difference between Britannia and bread. Nowadays 250 types of breads comes into the market internationally and nationally. The thing is, we were focusing about the product. Now we are focusing about the product life cycle. How much bigger life cycle we can have for a product, not the product. Of course, the quality has become important. For how many years the product can be accepted by the customer. So this has become the focus. So product life cycle is the main focus nowadays. We have shifted from product to product life cycle. We used to design 4 decades before also. We used to design the product. We used to design for manufacturing, we call in a mechanical term. But the thing is, now we are not designing, we are trying to innovate. Innovate means once you have designed a product, you have to improve the attributes, functionality, all kind of characteristics, quality characteristics to produce an innovation. So we are focusing from designing to innovation. We used to supply the product previously. Now the supplying is not an issue until unless you don't get a call from a company, sir, how your product is going on, are you getting any difficulty in maintaining it or whatever it is. This is called caring. So product need not to be supplied only, it has to be the customer need to be cared. One fundamental saying has been told, I think I should tell you, it's a very generic thing. It requires only 1/6 of the effort to retain a customer than to create a new customer. This is the fundamental thing all industries are following. So if you care the customer, it will be retained. So customer retention has become very important aspect nowadays. From just merely supplying the things to the customer is not a big deal nowadays. You have to care for the customer also. We used to have inspect the things. What was the previous regime? Even if we are talking of the quality, there were some parameters available, right? If the product is not conforming to the specification, what you do is you inspect this, reject this, and react it, or correctify, or maybe reactify it, and corrective action can be taken. But thing is taking action. Now the taking action is not a big thing. You have to add the value. So value addition, you see always say, value for money hai ki nahi, what a value has been added in this product. So the complete paradigm shift has taken place. The mind process or the thought process has changed. Now we are definitely we talked about economics, economical. Economical was the word. Now we are using the word value for money. Whether the product is, it does not mean you are not able to sell the Maruti product, 4 lakh product in the market in comparison to the Mercedes Benz. Only thing we'll see the Mercedes Benz in this bracket has some value for money because they have the competitors. Similarly in Maruti also in 4 lakh bracket you have the competitors. So value of money is the major focus nowadays what customers are looking for. We used to communicate. I think I'm very fond of this word collaboration. You see we are publishing papers nowadays, a lot of faculty is publishing papers. You see internationally every paper was designed to have, or maybe authored by 5 or 6 authors. Previously, if you go 20-30 years back, we have international publication. Every paper has got 5 to 6 authors and from a different strata, from a different system, from a different ecosystem. The reason was they used to collaborate because the collaboration brings you the better result and better publishing. So only thing is from communication, like only communicating to publisher or communication, the collaboration has become a buzzword. Until we do not collaborate, we are talking about collaboration between R&D organization, industry, and academia institution. If at all in India also, this circuit gets completed, we will have better results in terms of engineering output. This is my belief. So the collaboration between the industry, collaboration between the faculty, maybe collaboration between the interdisciplines, different disciplines, multidisciplinary research, this has become a necessity nowadays. And the next one is the real estate to intellectual property. We are talking of not real estate, maybe like essence, we are talking of IP. So India, it has like getting footing now, because in foreign countries we used to have IP systems available, but the focus is changing now. In India also, we are talking of IP. Whenever you go for collaboration, we talk of IP. Whenever you go for publishing, we talk of IP nowadays. Previously, what used to happen, somebody tells us something, we used to retain it in the mind, right? This thing has changed now. We have Google to retain it. But the thing is, now the Google has a lot of knowledge. Google is a resource. So many engines are working on that, available on this issue. But the thing is, now we have to manage our knowledge. That has become a focus. Knowledge is available online or offline or like whatever it is. But managing that, if you manage a computer, so management has become important. Even if you are getting difficulty managing the data in your computer. So that is also data management. But the thing is, you have sufficient knowledge available online, offline, but the knowledge management has become focus now. Next, please. And if at all I go through this, all such kind of challenges or paradigm shift, what is required at this point of time is, we are looking for everything can be answered by these three things. Maybe the customer focused product development process, there must be an excellent connection between the customer and clear product development concept definition. For example, the customer thinks of some concept, and if it is being realized in a day or like in some months, what is the kind of pleasure, what is the kind of delightness customer will have? And the customer delight is one of the most important motto of any of the industry nowadays. And if the customer, the concept product could be immediately, because there should be no time, concept will change. If there is a very, very less lead time between creating a concept and realizing the concept, so that is a marvelous thing. This is really required nowadays. Imagine the demand that could be created if the production could be synchronized with unveiling, like no time, like without any time you create a concept and it will be like the product is ready. So such kind of lead time can be reduced to answer all such kind of questions in terms of the history of product development, or the canvas of product development is the next. Is only the CAE. CAE is the answer to this, and you have to ponder over. These are the things where we have to ponder over and think over that how the CAE, the computer aided engineering, is going to engineer our future, engineer the innovation, engineering our disciplines. So upfront CAE is the key to success. Optimization, resources are always limited, so optimization word has to be inculcated in the minds of the people, into the industry, because with limited resource we have to optimize the things, and we have to be we have to be at par with the best in the world, because the quality is internationally accepted. We cannot enter into the international market unless we have the quality product. Lot of quality awards had been won by the Indian companies because we thought over the quality. 20 years ago, we were never thought of the quality, because we wanted to enter into the international market. We thought over quality. Lot of awards have been won by even the ICICI Bank on service sector and the manufacturing sector. So we have to be at par about the worst. Best part is benchmarking also. You can also go for benchmarking practices. Whatever the best is possible, you can always benchmark. And of course, need to be innovative to stay ahead. We have to be innovative in mind itself, otherwise you'll be washed out. We cannot move, we cannot retain in the market. So this is a very generic word, CAX. X means X belongs to, for example, nowadays if you talk about the CEO, CFO, CTO, lot of other things are happening. So this is, we call it a CX. So X is a very generic thing. So all kind of CX, computer aided technologies, is currently used at various engineering design. Even the CAD, you must have heard, mechanical students must have heard about the CAD, computer aided design and manufacturing. Then the computer aided engineering management, simulation lifecycle management, human capital management, customer relationship management, supply chain management, other tools like ERP, and the maintenance, repair, and operations. These are the things, these are the buzzwords, these are the technologies which is going to influence our engineering future. Very simple definition for those who are not from mechanical engineering, like a broad term used by the industry for the use of computers to design, analyze, and manufacturing product and processes. There is a difference of product and processes because we are following the process approach. Maybe few people are from MBA department, they understand what is the process approach or what is the product approach. There are 3 steps involved. One, whenever you are going for CA analysis, we have a background of FE, finite element method, and so many things. These are the softwares available, right? The thing is, one, we go for pre-processing, we create a geometry or 3D geometry in some software or modeling, you can say. Then it is shifted to some solver, which is also a software. It will analyze according to the parameters driven by you, and then we go for a post-processing, means you have to find out, evaluate the result, or note down the results, and you can take any action whatever you require. Now, most important thing is how this CA is going to help, because my theme of this talk is I just wanted to sensitize you people about the word of CAE, how it is going to influence and address the challenges faced by the industry in terms of the product development. This is the one-line theme of this talk. The thing is, one thing is the product development, of course it is going to enhance and leverage our product development. I will explain to you. Then we have a simulation available, because simulation is a great thing nowadays. Modeling and simulations go parallel to each other sometimes. Optimization is a key to success. Then we talk of innovation, then we talk of demand-oriented research, because I told you, if the customer has some demand, and if you are able to realize it in terms of the product, so the customer delight will be enormous. And we are talking of engineering intelligence, which is an offshoot of all such kind of CAE processes. First, I'll explain to you what is product development. Normal thing, what happens in a product development, there are some stages, which is called horizontal stages or horizontal line. We go for a research, market research first. Then we go with after this research, we come up with a concept, that this is the concept, what market is looking for. Then the concept is seen from an engineering angle, and we do all engineering technology. We apply what is the technology available, what is the engineering aspect of this, and it is ultimately shifted to the manufacturing, and of course after the product is manufactured, we go to the marketing. This was the normal product development process going on. Now, what used to happen 3-4 decades ago, research wing was, every wing, every part, every node of this was acting separately, right? So once the product is marketed, then only you come to know that this is the product and which is not accepted by the customer, right? Maybe engineering, then they used to say this is engineering fault, or is a manufacturing fault, or is a concept fault, or is a research fault. So nobody used to decide the things, and they used to reinvent the wheel, but this thing is not possible. This is not called, it was a traditional product development. Now it is a parallel product development process. Every aspect, right from the customer research to the marketing, everybody has been sit in is a circular meeting. Everybody has to be taken into account, and it goes parallelly. So this is called parallel product development process, because the results are very fast. There is no communication gap between different wings. So this is the way, and this parallel product development process can easily take place with the help of CAE. So this is because in a product development process, we use the virtual environment. Everything is available virtually on a computer in a virtual environment. And once you go for clearance, in a normal products, we have to go for 1, 2, 3 clearances. Then you have to start a production takes place. In virtual clearance takes place by using this virtual environment. All virtual clearance take place from 1, 2, 3. So this segment 1, 2, 3 has been shortened with the help of the virtual environment, and you get the product development has become easy, it has become faster, it has become more efficient, it is more relevant to the customer. So these are the benefits I have written, which it is developed faster and validate faster. Then this is involved from the integration of modeling, simulation, and visualization facilities with the other product lifecycle management software tools, reduction of physical prototypes. We used to have physical prototypes first. Now we have virtual prototypes available. Whatever you want to modify, you can always modify on computer itself, and probably any of the results can be seen on the computer itself. Integration of all the global participants by providing a single source of information in the global collaboration platform improves quality. What is simulation? You must have heard about the word simulation. Normal, I've given a very simple definition. It is an attempt to model a real life or a hypothetical situation on a computer so that it can be studied how the system works. In simulation, you can see how the things are working. A lot of simulations are available in videos or MOOCs or whatever online courses available. This is all done in a simulation way. So this is how the sim works. Every kind of virtual testing takes place on computer itself. You cannot predict so many things once you are in the air. Once it is landing, how the crashing effect will be there, how will be the load impact will be there, what will be the forces on the wheel itself. Everything can be done on computer itself in the form of a simulation. There is two terms. One is called topology and one is called topography, right? So how this simulation is being used for topography and topology optimization. There is a difference between topology and topography. Like whenever you are considering the density variation of mechanical engineering students, it becomes topology, otherwise it's a topography. So this simulation is very effective in both kind of things. So you are using space. I can give you the best example. Once you are using the car, you see the Honda City, like how the materials have been reduced. Like once you open a door or whatever it is, it has been redesigned. If you see a car 10 years before and the same car 10 years after, like this, the CA is an influential kind of thing. So all kind of material optimization with the same strength and the same other factors, which has been done with the help of CA. And let me tell you, like CAE has a wonderful future in automobile industry. It is very well used in automobile sector, but however it is not limited to automobile sector. I'll give you the complete kind of sectors where CAE is being used. How many of you have heard about Industry 4.0? Industry 4.0. We are looking for industry for the fourth level of industry. We call it the fourth level industry where we are looking for intelligent systems. How many of you have heard about IoT? IoT, Internet of Things. Have you heard about? Right. Okay. So IoT is a part of Industry 4.0. What we are looking for nowadays in industry, it is like first level or second level or third level or fourth level. We are looking for the intelligent systems. Intelligent systems means where the prediction and the diagnosis and the reaction takes place automatically as our brain does. Very, very simple language I'm telling you. We are talking of that kind of system which is biologically inspired, or like it works like a human brain, like all automatically maintenance takes place, everything takes place, takes the decision and rectify it. Such kind of systems are required nowadays. So this is how CA is going to be influenced this Industry 4.0. This is called predictive simulations. So whenever you have to predict yourself, you are in for example, you have to you have to send some of the vehicle to the Mars. So you cannot predict so many things over there, what is going to happen and what is going to the impact load or whatever it is. The thing is, you have to predict only, you can only imagine that this is the prediction over there, this can be happen there, and you have to prepare for the set kind. So the systems are so prepared that they will react to such kind of actions or whatever is happening over there automatically like our brain does. So I'll give you the most important thing is some of these self-repairing structures. In civil engineering, we are looking for self-repairing structures. We are looking for structures which is biological inspired. So this kind of simulation, predictive simulation, is going to help our future and engineering innovation, which comes under Industry 4.0. I told you what is optimization. Optimization is 3 key success: time to market. We have to reduce time to market. You have to innovate the product. Of course, you have all resources available, you have to optimize the resource efficiently and effectively. Both of the things are very important, and the product performance is one part. So if you use this CAE optimization, you will get the results. How many of heard has additive manufacturing, 3D printing? Have you heard? Yes. Now the next stage is of 3D printing now, or additive. There is no subtractive, people are shifting. Of course, there are some limitations available. We are not able to address those challenges, but the thing is, in case you are going for customized product, 3D printing is the best one. And a lot of good 3D printers are happening now. I tell you, like, because next decade is of 3D printing, and CAE has got very true supplementary like tool to this 3D printing, right? Once you make a product through CAE on a virtual environment, put into the programming part, put into 3D printing, you get the desired result. So the thing is, the complexity has been reduced. Maybe whatever the complexity of the product is available, the 3D has like done it wonderfully, because complexity is almost free now, and it is available through 3D printing. Normally we used to like have challenge with the complexity, so CAE could not address the complexity, but this complexity has been like solved by the 3D printing. So CAE and 3D printing has become very supplementary to each other, and it is going to like produce the very desirous or enormous results. I'll give you an example. This is titanium bike frame. It has been like made by a 3D printer, right? It is the Empire cycle only. This is the only cycle available which has the kind of same strength and same like whatever the factors are required, used by like or the manufactured by CAE as well as 3D printers. This is the like normal, like you can see your like daily usage things in like any of the like market or the Walmart or whatever market you go. These are things that are available. You know, the shape has been always like defined by using the CAE, because the shape has so many like factors governing. So it has to be light also with the same strength also. It should to be withhold whatever weight you are putting in. So such kind of examples are easily possible. We can optimize our material, time, whatever it is through CAE only. Since we are talking of how the optimization, CAE and innovation takes place simultaneously. This is a perfect example of innovative design in automobile, where the complete CAE interface has been used, right? Complete optimization has been done by CAE tools. Lot of software is available in the market, right? And this they have come with the innovative design in automobile only. I'm putting an example of automobile because people are excited about automobiles or mobiles nowadays, the young generation. So innovation, if you go with this slide, how do you define the innovation? What is desirable to the users? What is possible with the technology? And what is viable in the marketplace? If you overlap it and you come up with a proposal, that becomes innovation. Otherwise, if the innovation has been done and it is not accepted by the customers, there is no innovation we call. If it is not accepted by the customer, it is of no quality. So ultimately the thumb rule is the customer satisfaction, but whatever is desirable by the users, so you can make this innovation very easy, very simple and very better with the help of CAE. If you have simulation driven innovation, if you are using the simulation interface which has been like given by CAE, these are the advantage. We can extend human creativity, like we can have a better platform, better canvas to play with, better playground to play with, so creativity improves. Then we have non-intuitive solutions available, broader exploration space available, wonderful space available, greater insight, and the right answer is the faster. We can innovate faster with the help of CAE tools. And one of the most important aspect is all kind of such innovation, optimization, simulation, product development process. This leads to engineering intelligence, what we are looking for in Industry 4.0. If you use this, like CAD is a like computer-aided design, the modeling, 3D design, whatever the things are available. If you this product development like management, and from the lower side, if you go for engineering data management, which is more important, the data management has become very like, because a lot of CSE IT students are there, data management has become really a field nowadays, how to manage the data, how to mine the data, how to like tackle with the big data or the small data. So this is the real field. If such kind of engineering data management takes place and we have the CAE interface available, so all such kind of things from upper layer and the lower layer leads to the engineering intelligence, which we are looking from Industry 4.0. This is an example of engineering data management. How the engineering data is available. Data is available digitally now. Data is available on different geographical locations. We need not to reinvent the wheel. For example, some car has been invented or innovated in US. The data is available with the company. That can be shared in India also. So you can work on that particular data and improve the things. So innovation can take place. You can change the styling or whatever the attributes you are required. Similarly, like different models, enormous data about car models. I'm putting the automobile sector only. We have the data related to every component available. We can improve the component itself. How to improve the efficiency and effectiveness of the component. So and lot of iterations are possible because virtual world is there, you can have thousands of iteration. So once all such kind of management is done, it always leads to, with the help of CAE and SCAD or PDM or EDM, it leads to engineering intelligence. I'm just like putting what is the kind of like canvas we can, like CAE is being using nowadays, right? It is applicable to aerospace industry, it is applicable to electronics industry, it is applicable to, I showed you one slide on the consumer goods, it is applicable to automotive and transmission, it is applicable to life sciences and biomedical. Even people are using like CAE in heart surgery, they're using in heart surgery. And what is the kind of, I can put an example of health industry, we are putting in a stunt in, like whenever you are using the heart surgery, that pressures and everything can be done, all kind of simulation takes place in a virtual environment first. We can select the material, we can select the composite, we can select the alloy, whatever is required, we can always modify in virtual environment and use there in human body, right? Heavy industry we are talking about, if you are talking of wind energy or maybe the wind turbine, the wind turbine profile can be changed itself in the virtual environment, right? And that creates the better output, better efficiency, whatever is required from this wind turbines. Similarly, energy side, engineering on structure, we are talking of civil structure or like maybe architecture or what a complex structure. So CAE is applicable on all such kind of domains. So this is a concluding remarks. I'm just trying to finish it up. This is like very well written, like in a one complete line. Probably the future will be defined. The future high-tech systems will be complex system of systems. We have like lot of research taking place in like reliability area or very complex systems. Maybe these complex systems can be bifurcated into small kind of systems which can be handled individually and become a part of the complex systems, right? Developed through just-in-time. Have you heard about just-in-time collaboration? Like when there is no lead time available and probably engineering data is available across, we are using the complete digital world for this purpose. Collaborations of globally distributed teams linked seamlessly by an infrastructure of network devices, tools, facilities and process. Here you see the every discipline comes into picture. If you are talking of the complexity of the system, it is a reliability part. Electronics and mechanical people can take care of this. Even the electrical people can take care of this. But thing is, just-in-time collaboration is the managing kind of things because the data has to be collaborated between different corners. It has to be the networking devices we need, electronics, the tools, facilities and processes. All such kind of disciplines come into picture whenever you are talking of CAE tools or CAE driven maybe CAE driven engineering equipments. The effective use of immersive 3D virtual worlds will facilitate both the process and the product innovation. We are focusing on product innovation, but we are also focusing on process innovation. There is a process approach available. We feel that the whole of the complete functionality has been broken into small processes. We have to work on each process. We have to innovate in each process so that the complete process is optimized or better in a better form, or maybe we can have desired result out of the complete process. The most compelling motivation for a fundamental paradigm shift for CAE and virtual product creation will be the future ambient intelligent environment when the devices and facilities will be able to react intelligently to the user's gestures, actions and context. This is exact Industry 4.0 is looking for. We have to have the kind of intelligent environment where actions, gestures, context can be taken very intelligently, just like your human brain does it. These are the references from which I made this presentation, and I'm thankful for the Altair Engineering Corporation, is a US-based company who provided me some of the videos which I was able to show you or share with you. Thank you very much.